Hello, welcome back for another math lesson with Mr. Hopkins. Today we are looking at functions again. Just a review from the previous lesson. A relation is a function when, first of all x's are different. How's that? Remember, each x could have only one y. So each member in the domain could only have one member in the range. And also, if it's a graph, if you plot your points, it passes the vertical line test. And that's where you draw a vertical line, and if it only ever hits it in one spot, then it's a function. Okay, so let's just review the previous lesson on functions. Which relation is not a function? So I'm looking for one whose x value may have multiple same values. For instance, in 1a, the x values are 1, 2, 3, 4. If they're all different, it's a function. So I'm looking for one that's not a function. Part B is 4, 2, negative 3, 3. They're different. Negative 1, 1, 2, 1. So in C, 1 goes to 3 and 1 goes to 7. So that x value has multiple y values. So that is not a function. And if I plotted those points, it would not pass the vertical line test either. Okay, number 2. Which relation represents a function? So once again, looking for all different. Those are not different. Negative 7, those are not different. 6 and 6, not different. These ones are all different, so that is a function. Label each graph as a function or non-function. This is a function. It passes the vertical line test. This is not a function because I hit it in more than one spot. Let's see here. This is a function, and this is not a function. Okay, so that's a review of functions. We're going to jump into function notation now. We read this as f of x. In the past, we've seen it looks like f times x, but that's not the case. These are functions that we read this as f of x. And all f of x means is y. It's our output. So if this is our y, this is our x, that's our input. So f of x is our output. It says evaluating functions. For f of x equals 5x, find f of x when x equals 6. So all I'm doing is substituting in 6 wherever I see an x. So f of 6 equals 5 times 6, which is 30. Just because we change the variable doesn't mean anything. G of t is still a function, and it means y. So g of t equals 2.30 t plus 10. Find g of t when t equals negative 5. So once again, plug negative 5 in wherever I see a t. So 2.3 times negative 5. Negative 11.5 plus 10 is negative 1.5. Excellent. Okay, consider the rule. Remember, we've discussed this before, that a rule is an equation, right? Multiply the x by 2 and then subtract 1 to get the y. So y equals, to get the y, we multiply x by 2, and then we subtract 1. So 2x minus 1. It says fill in the table below. So now we have an equation of a line, y equals 2x minus 1. I can go ahead and put that into my calculator. Go to y equals 2x minus 1. And I can go to my table, second graph. And they want us to, they already picked our x values in the table, 0, 1, 2, and 3. So on my table in my calculator, 0, 1, 2, and 3, I get negative 1, 1, 3, 5. Or I can plug all these x values in for x and do the math, and it does generate all of these. It says write an equation to represent this verbal description. Kind of jumped the gun on that. Here's my equation, y equals 2x minus 1. Part B says graph that function rule. So 0, negative 1, 1, 1, 2, 3, 3, 5. Looks like it's going up like that. Y equals 2x minus 1. And use your answer from part B, that's this graph, to determine what input would produce an output of 17. So I want an output of 17. 1, 2, 3, 4, 5, 6, 7, 8. Go way up there. Wow. Well, I'd have to extend my graph paper, or I can use this equation right here. If I want the output to be 17, remember my output is y. I can say 17 equals 2x minus 1. I can plug 17 in for y and solve for x. So plus 1, 18 equals 2x, and divide by 2. So when x equals 9, that's my input, x, then it would generate an output of 17. So you can just substitute it into the equation. Perfect. This is more on functions. I hope you found it beneficial, and we will be using it later. Good luck.